Hello and welcome once again to Mathspirational. This is going to be my first video in a series of videos looking at finding gradients of curves. Now, before we start looking at them, I'm just going to go over some notation that we'll be using which you may not have come across before. I'm going to start by looking at the Greek letter capital delta, x. This simply means a large change in x. Now, what do I mean by a large change in x? Well, I mean something on a sort of macroscopic scale. So things of units are bigger. So 1, 5, 7, 52. So delta x simply means a large change in x. Delta y would mean a large change in y. Delta t would mean a large change in t, and so on. So if capital delta t means a large change in, you can probably work out that a lowercase delta t means a small change in x. And again, what do I mean by a small change in x? Or in y or in t? Well, if capital delta x means things like 1, 2, 5, 72, a small change in x is going to be effectively decimal changes. So changes of a tenth, a hundredth, a thousandth, a 10,000th. So small, but finite. Now in mathematics, particularly a branch of mathematics we're going to be looking at, we have a scale below this small scale, below this microscopic scale. And we show that scale by using a lowercase d. So what's smaller than microscopic? Well, infinitely small, or infinitesimally small. So dx or dy or dt or dv means an infinitely small change. Now, those of you who've done some mechanics and we're wondering why we don't use s for distance and displacement, this is part of the reason. Okay. Kinematics, as soon as you go to non-constant acceleration, involves a bit of finding gradients of curves, and because of that, d is already taken up. That's one of the reasons, not the only reason, but that's one of the reasons why we don't use d for distance and displacement. So that's three bits of new notation. In addition to that, we're also going to have limit notation. Now, lots of courses on this area of mathematics don't use this at the start anymore. When I first learned this back in the mid-90s, it was part of the course. However, lots of courses in A-level maths and A-level use maths don't use this. I'm going to. It involves a little bit of understanding, but once you've got that, it actually makes the maths a lot easier. So what does this mean? The limit as delta x tends to 0. It means, imagine what happens. What happens as delta x gets really very close to 0. Okay. That's the notation we're going to be using over the next few videos. I hope that helps. As always, if you liked it, please like and subscribe. Thank you very much.